Hello, Luke. Welcome to lesson 17. So today we're going to be talking about factors, coefficients, terms, and the distributive property. So we have quite a bit to get through here. So let's go ahead and get started. So to start with, we're going to get a few terms figured out here. Let's start with factors. So what is a factor? You may recall from previous years, when you have a multiplication problem, let's say 6 times 8 is 48. Hopefully you recall that these numbers each have a name. So the first number in a multiplication problem was called the factor. And then the second number is a second factor. And then the answer is the product. You might recall this from previous years. Sometimes in different textbooks, they'll call the first number the multiplier, and then the second number the multiplicand, and the last number is still the product. So depending upon which math book you looked at, you may find different terminology for these numbers in a multiplication problem. What we're going to go with is the first one. So we won't be talking about the multiplier or the multiplicand. We're going to be talking about a factor and a product. So whenever we have multiplication, the numbers being multiplied by each other are called factors. So in algebra, we write this a little bit differently. We might write it as 6.8 equals 48. And if I were to ask you, what are the factors in this problem? The answer is the 6 and the 8. So the 6 is a factor and the 8 is a factor in this case. I could also write this as 6 times 8. Again, 6 would be a factor, 8 would be a factor. I could write it as 6 times 8. This would also be two factors, 6 and 8. They are the numbers being used in a multiplication problem. Now, in algebra, we also have variables. So we can also have something like this. We could have 6 times y. All right? Now, 6 times y is a multiplication problem. We would write it as just simply 6y. There's that invisible multiplication sign there because, of course, we can't solve this. We don't know what y is. So we just have 6 times y, or 6y. All right? But again, the same terminology holds. So this 6 is a factor and this y is a factor. They are both factors of a multiplication problem. Now, if we write it without the dot, such as 6y, or maybe we'll add another variable, maybe 6yx, right, where we have several things being multiplied by each other. So this is something that we would call an indicated product. Maybe I'll write that. This is an indicated product. And all that means is that we don't have an actual multiplication sign between these numbers and letters, but there is an invisible one. There's an indicated one, and that is the dot between these. So this is really saying 6 times y times x. It's all being multiplied. So again, this would be an indicated product. 6 is a factor of that product, y is a factor of the product, and x is a factor of the product. So that's all that we need to know really at this point about factors. They are just the number or letters used in a multiplication problem to be multiplied by each other. And then, of course, the answer, the solution, is called the product. So this would be, in this case, this is kind of our product, which you might argue isn't a very good product because we don't really have anything more than what we had here. 6 times y, 6y. It's an indicated product still. We don't have a final number answer. All right, so we have factors making up the indicated product here. Okay. All right. So that is a factor. Now let's talk about a coefficient. All right. So what is a coefficient? All right. And for our purposes, we're going to consider a coefficient the number of an indicated product, or the number inside an indicated product. So if I go back to my 6yx, all right, For our purposes, we're going to consider the coefficient to be the number within that product. So 6 is the coefficient. All right. And just to keep things straight, whenever we write indicated products, we're always going to write the coefficient first. So you could argue that this 6yx could also be written as y6x. Because if you recall, multiplication is commutative, which means we can reorganize the order in which we multiply, and it's not going to change the answer. So we could certainly reorganize these letters and numbers into a different arrangement and call that equal to this one. And it would be y times 6 times x is equivalent to 6 times y times x. But so that we're uniform in how we solve problems, we're always going to write these indicated products with the coefficient at the beginning. And remember, we said the coefficient is the number in that expression. So we're going to write that as 6xy. Another general rule is to always write your variables, the x and the y here, in alphabetical order. All right. So even though this would be equal to 6yx in value, there's no difference here. We're just rearranging the x and the y. It's multiplication. We can do that. There is no difference between these two. But again, in order to solve these problems uniformly, make them easier to read, we're going to write them in alphabetical order. So we would write that again as 6xy. All right. So if I give you another expression, let's say I've got an indicated product such as 3 times A times B. Yeah, let's throw a C in there, times C. All right. I could write that like this with my dots indicating multiplication, or I could write that in a simpler form as 3ABC. All right. That would be my indicated product. Now, if I were to multiply, let's say 4, actually, let's start with maybe a W times 4 times Z. All right. And I asked you to simplify this. You would go, okay, well, W times 4 times Z, it's all multiplication. I'm going to rewrite it with my coefficient coming first. And the coefficient is the 4. All right. And then I'm multiplying that 4 by a W and by a Z. Well, which one comes first alphabetically? The W does. So we're going to put the W and then the Z. So this would be the proper way to write that indicated product, 4WZ. Okay. All right. So pretty straightforward here. So we're just kind of getting some terminology out of the way. So once again, just to recap real quick, you've got the number in an indicated product. That is your coefficient. All right. And we put the coefficient at the beginning of the indicated product. And then we have each of them, the variables, the W, the Z, and the 4, each of them would be considered a factor of the indicated product. All right. Very good. All right. Let's move on. Let's talk about terms. So when we talk about terms in algebra, we have some pretty complicated expressions that we're going to be getting into. So let's just throw one out there. Let's say I've got an expression that looks like, I don't know, z plus 2ab minus 4ac over, sorry about that, 3 minus 5b plus, we'll just go a 6 ABC. All right. So we've got this fairly complicated expression. And in order for us to be able to talk about them more clearly, we've developed kind of a language that we use for these expressions. So we give names to certain parts of this expression. Excuse me. And one of the names is going to be a term. All right. Let's write that down. A term. So what is a term? All right. It's fairly straightforward. A term is either a number or a letter that's all by itself. That would be considered a term. So for example, if I have X, that is a term. If I have 3, that is a term. All right, so if it's a number or a letter all by itself, it's considered a term. Okay. If it is an indicated product, then the whole indicated product would be considered a term. So if we have something like 3ABC, this is an indicated product with the coefficient 3. This whole thing would be considered a term. All right? The 3 is not by itself. It's with the A and the B and the C. You can picture it that way. So this is all being multiplied. It's all one term. It's an indicated product, one single term. Okay? Hopefully that makes sense. Another way that you can have a term is to have an indicated quotient. Now, we didn't talk about quotient, but hopefully you recall that quotient is the answer to a division problem. So just like a product is an answer to a multiplication problem, a quotient is the answer to a division problem. So another way that we could have a term would be if we have an indicated division problem, an indicated quotient. All right. So an example might be, we could do pretty much any fraction, because remember this fraction line here indicates division. It's just another way to write division. All right. So 3/4 would be considered a term. Why? Because it's a quotient. It's an indicated quotient. All right. So this would be a term, one term right there. Now we could expand on that and make it a little bit more complicated. We might have 3xy over 4ab. All right. Is this a term? Well, the answer is yes, it is, because we have an indicated division problem. Okay, an indicated quotient. So we have this top term, 3xy, is being divided by the bottom one, so we have one full term. Now, you might actually, and I might have just actually kind of said that, you might kind of think of this top 3xy as being a term all by itself. Generally, we don't do that if it's in a division problem. So we kind of consider this division problem to be one full term, even though you might argue, well, it looks like there's a term on the top and a term on the bottom. You are in part correct, but for simplicity, when we have a division, we're going to consider everything within that division problem, whether or not there's multiplication or addition or subtraction or anything going on in the top and the bottom. We're going to consider that whole division problem as a single term. All right, so just follow that division sign. Okay. All right, so those are different ways that you can arrive at terms. So now looking at this expression up here, how many terms are in this expression? Let's think about that. How many terms are in this expression? All right, and if we look at it, we're looking for these things. We're looking for numbers or letters by themselves, or we're looking for indicated products, or we're looking for indicated quotients. All right. So if we look, we might say, well, here's a z, and it's all by itself. There's no product. There's no quotient here. It's all by itself. So z would be one term. And this actually brings me to another point. When we find terms, we're always going to include the sign with the term. That'll be very important later on. So we're going to include the sign with the term. Okay, so this term, we're going to write it as a plus z, a positive z. That would be a term, positive z. Just don't say z is a term. No, no, no. Keep the sign with it. It's a positive z. That's the term. Okay. Now here, if we move on, we have 2AB. Well, what is that? That is an indicated product. So this, again, I'm taking the sign with it. This positive 2AB would be another term in the problem. Okay? Going on to the next one, we might see right away we have a division problem, which means we have an indicated quotient. All right? And of course, that indicated quotient makes up a term. So keeping the sign again with the term, this would be another term, the negative 4AC over 3 minus 5B. Okay, that would be another term. And then lastly, we have a 6ABC. Well, that's an indicated product. There's multiplication going on there. So again, that would be a term. So in grand total, we have 4 different terms in this expression. And that makes it a lot easier to talk about this expression, because I might say, look at the third term in this expression, and you'll be able to right away recognize, oh yeah, we're looking at this part of the expression right here, because we're looking at the third term. So when we get into complicated problems, it's nice to know this terminology so that we can talk about it clearly. All right. Excellent. Let's see here. Moving on. I think that pretty much settles terms. Let's move on to the next section. And in this section, we're going to be talking about, and I'm just going to make a little room right here, a new concept, but is supremely important. So this is very, very important. Pay attention here. You're going to be doing this a lot, and it's very important that we understand how this works right now. So we're going to be talking about something that's called distributive property. Okay, distributive property. Very important. And to begin our discussion on that, we're going to start with a problem. We're going to start with an example. Let's say I've got an expression that looks like, this. All right. And I told you to simplify this. Well, you recall that up to this point, we've always said, do the parentheses first, right? So you would solve this by taking, let's go with a different color. Let's go with green. So let's take the 2 plus the 3, which is a 5. So we'd put that in our parentheses. We have a 3. So we have a 3 with an invisible multiplication sign. 3 times the 5, which is going to be 15, right? That's what we've been doing up till now. Easy peasy. All right. Now, let's take a look here. What if we were to do something different? And actually, you know what? We'll make this black. We're going to rewrite the problem. What if we go 3, 2 plus 3, and we say, okay, let's take this 3. We're not going to do parentheses first here. Let's take this 3 and the invisible multiplication sign, and we're going to take the 3 and multiply it by the 2, the first number inside the parentheses. All right? So we go 3 times 2. What is 3 times 2? Well, the answer is 6, right? Now we're going to take the 3 again, and we're going to multiply it by the next number in the parentheses. So 3 times a positive 3 is a positive 9. So we're going to write positive, notice I'm keeping the sign, positive 9. Okay? Now, what's 6 plus 9? The answer, 15. And if you notice, isn't that exactly the same as this 15 over here? They are equal to each other. I did it in a different way, but I got to the same answer. This side, this solution, is a demonstration of the distributive property. All right? The distributive property. So very, very important. So how does it work? Well, we are saying that we can take multiplication and distribute it over addition. All right? I know that sounds complicated, but all that means is that we're able to take a multiplication problem That's the first key here. It has to do with multiplication and addition. All right, that's the key. So if we have a multiplication problem where we have a number, or it could be a variable, being multiplied by something that's being added, so something within parentheses, okay, something within parentheses. If you have multiplication being multiplied by something that's being added within parentheses, we can distribute that, in this case, that 4 through the parentheses, over the addition is another way to say it. Distribute the multiplication over the addition. All right, and the best way to think of that is to think in terms of these arrows. They're very helpful. So what we're doing is we're taking this 4 and we're multiplying it by the 3. Okay, the first one, we're taking the multiplication, multiplying it over the addition, and then we're taking that 4 again and we're multiplying it by the second number inside the parentheses. All right, and then we're adding those two products together. So we have the 4 times the 3, and we're adding that with the 4 times the positive 4. All right, that is what the distributive property is doing. So just study this for a second. Make sure you've got this clear in your head. We're taking the 4 times the 3, and then we're adding that, always adding that to the 4 again, being multiplied by the next number, which is the positive 4. All right. Once we do that, we can solve those multiplication parts here. 4 times 3 is 12. Plus sign. 4 times 4 is 16. 12 plus 16 is 28. That is our answer. And notice that is the same answer that we would have gotten if we would have done the parentheses first. 3 plus 4 is 7. 7 times 4 is 28. All right. That is how the distributive property works. And it is so very, very, very important. And you might say, well, Jim, I find it a lot easier to add the parentheses and then multiply that by the 4. Well, that is true in this case. But what if we don't have numbers in that parenthesis? What if we've got something that looks like this? What if we have, y times x plus 2? Something like this. All right. Well, now you can't do the parentheses first. You don't know what the x is. So you can't do anything in here. And so if you can't do the parentheses, well, then you can't do the rest of the problem because the rule was you had to do the parentheses first. Okay. So in this case, how would we do it? Well, we would use the distributive property. So we would take the y, multiply it by the x. And then we take that y, multiply it by the positive 2. Okay, so y times x is what? Well, we don't know what y or x are, so it's just yx, the indicated product, yx. All right, and then we're adding that, again, always adding, y times the next number, which is a 2. Well, we're going to write the coefficient first, so we're going to say it's 2y. All right, this is our answer. This is our solution. This is as far as we can take it, well, given that we don't know what y or x are. All right, and how did we get there? We got there using the distributive property. So once again, let's just try a couple of these problems and see how we do. So looking at this problem, we have a 4, and there's the implied multiplication times the set of parentheses. Okay, let's use the distributive property. Now we could solve the parentheses first and then multiply that by 4 as we've done in the past. But here I want you to use the distributive property. So go ahead and pause the video here and give this a whirl on a piece of scratch paper, and then we'll do it together and see how you did. All right, so we're going to use the distributive property. So 4 times 6. Let's start there. 4 times and keep the sign with it, times a positive 6. So 4 times a positive 6 is going to be a positive 24. So we'll just write 24. Okay? Now, we're going to be adding that to the next product. So now we have the 4 times the next number, and keep the sign with the number. So this is 4 times a negative 2. So 4 times a negative 2 is going to be a negative 8. I'm going to put that in parentheses. The only reason I'm putting that in parentheses is I don't like two signs right next to each other. I have this plus sign. If I didn't have this in parentheses, I'd have plus minus 8, which is just awkward. So I like to put it in parentheses if we have two signs, in addition and subtraction, right next to each other. All right. So we have 24 plus a negative 8. Now we're going to add that to our next product, which is going to be the 4 times the positive 5. So 4 times a positive 5 is a 20. And notice I have positive 20 already because I have this positive sign, so I don't need to write another positive sign. It's positive 20, which is positive 20. Okay. Now I'm going to be adding that to the next one, which is 4 times the negative 7, which is a negative 28. And again, I don't like positive, negative in a row, so I'm just going to write that as a parenthesis, negative 28. All right, so now I have distributed the 4 through all of this addition, over all of this addition. Okay, now I can simplify. So I have 24 plus a negative 8. Well, 24 plus a negative 8, in your head, you can think of that as the same thing as 24 minus 8, which is 16. And I've got plus the 20. And here again, plus a negative 28. You could think of that as just minus 28. Okay, so 16 plus 20, well, that's 36. 36 minus 28 is what? 8? 36 minus 28 is 8. So we have a final answer of an 8. All right. Now, if you wanted to check that, in this case, it'd be pretty easy to do. Let's just solve the interior parentheses first and multiply it by 4. So 6 minus 2 would be 4. 4 plus 5 is 9. 9 minus 7 is 2. And then the 2 times the 4 would give us 8. So there you go. We know we did it right. All right. Now let's use some variables. So go ahead and look at this next problem and solve it on some scratch paper, and then we'll look at it together. All right. So looking at this, we have an xy times the quantity a plus b minus 2c. Okay, so what are we going to do? Well, first of all, we can't do x minus y. We can't do anything with that. We don't know what x and y are, so that's as simple as we can get it. So we're going to now take this indicated product right here, the xy, and we're going to multiply that through by each term inside the parentheses. Because remember, each of these is a term. They're all by themselves. This is all by themselves. That's a term. This is a term. It's all by itself. This is an indicated product, so that's a term. So we have 3 terms inside here. So we're going to multiply this xy by each term inside the parenthesis. So xy times a, well, we don't know. We're going to write that as an indicated product, but we're going to write it correctly in alphabetical order. We're going to put the a first. A, x, y. All right. Then we have plus and xy times the next term, which is the positive b, which is, again, if we put it in alphabetical order, is going to be the bxy, right? And then we're going to multiply it again by the third term here. So we have xy times the negative 2c, which is going to be a negative. And if I wanted to, I could put the plus. We are adding here. So plus negative 2. And I'm going to put them in alphabetical order, C, and then the X, and then the Y. So, of course, I can't actually multiply those. So there we have everything distributed. Now we can just start adding. And there's really nothing to add here because they all have variables. and we don't know how to add like variables. It wouldn't matter anyway. There aren't any like variables here. So AXY plus BXY. Now this plus minus, I can just write that as a minus. Whenever you have plus minus, it's always going to be a minus 2CXY. That's as far as I can go. I can't add or subtract anything else in here. So that is my solution. All right. All right, let's go on to the next one. And again, give it a whirl on your scratch paper, and then we'll do it together. All right, so let's try this out. We've got a 2m, and we're distributing that through. 2m times the xy. All right, well, that's going to be a 2, and we'll put them in alphabetical order, m, x, y. Right? Now we're going to take that same 2m and multiply it by the next term, which is the negative 3p. Now 2m times a negative 3p, and I could say this is a plus, I guess I'll continue to do that. 2m times a negative 3p is going to be, now I can multiply the 2 and the 3. That I can do. So the 2 times the 3 is going to give me a negative 6 because it's a negative 3, right? 2 times a negative 3 is a negative 6. And then I still have the m and the p that are being multiplied there, which I don't know what they are, so I'm going to write them as mp. So I end up with negative 6 mp. Do you see how that worked? This 2m times this negative 3p. All right. Again, this is all multiplication, right? There's a negative sign on this 3, but he's still being multiplied by this 2m. He's still being multiplied by the p. So everything is being multiplied by each other. So it doesn't matter what order I do this in. And therefore, I can take this 2 and this 3 and multiply those two together to get the negative 6. And I'm still left with an m times a p, right? So hopefully you see how I got that right here. Now we can finish this out, and all that's left really is to just recognize that whenever we have a plus minus like this, the minus is going to win. We're going to end up with 2mxy minus 6mp. All right, and that is our solution. All right, let's do one more. And again, do it on your paper, and then we'll do it together. All right, so we're distributing, in this case, a negative number. So that's the key to recognize here. This is a negative 3. Keep the sign with the number. So we're distributing the negative 3 through the parentheses here. So negative 3 times the first term. So a negative 3 times a 2x. So that's a negative 3 times a 2 times an x, right? And remember, we can then multiply these two numbers. So a negative 3 times a 2 is a negative 6. We still have that being multiplied by the x. So negative 3 times a 2x is going to be a negative 6x, right? Now we're going to take that negative 3 again. We're going to distribute it through to the second term, which is the negative 4. So we have a negative 3 times a negative 4, which is a positive 12. Right? And that's as simple as we can get this. That is our answer right there. All right. So hopefully that makes sense, Luke. Just when you do these problems, I would highly recommend using the arrows for right now, just to kind of get yourself in the habit of knowing what's being multiplied by what. Later on, this is going to be, hopefully, become second nature to you. You won't need to use the arrows. You'll be able to kind of do that in your head. But for the moment, I think it'd be good to use the arrows, at least for this lesson, and just recognize how you're distributing through that number, the outside number, the first factor, I should say, into over the addition that's going on within the parentheses. Okay. Very good. So we will stop here, and you can work on this seat work, and we will continue tomorrow.